Our lecture for today is the velocity of sound, by means of a resonance tube closed at one end. What is sound? The word sound may be defined in two ways, objectively and subjectively. Objectively, the sound is a type of wave motion taking place in a material medium, whether gaseous, liquid or solid, due to an original vibration, or mechanical disturbance set up by a sounding body. Subjectively, it is a sensory experience in the brain conveyed to it by the auditory nerves of the ear. Sound is a type of wave, so are light and earthquake tremors, wave that are periodic and go through several cycles before dying out. For example, the sound from a tuning fork is a continuous wave. The sound from an explosion is not. The cause of continuous waves is a periodic motion. Sound passes through matter by transferring energy through particles. The particles hit the other particles next to them, and the wave is formed. Sound has no absolute speed. The speed of sound depends on the material it is passing through. For example, sound travels much faster in water than it does in air. This is because in the air, there aren't as many particles for the other particles to knock into. This causes the sound to lose energy faster and disperses more quickly. Sound, it is the audible waves, between 20 Hz to 20 kHz. Infrasound, refers to the sound frequency below the normal hearing range, or less than 20 Hz. Ultrasound, refers to the sound frequency above the normal hearing range, or more than 20 kHz. Reflection, refraction, and diffraction. Like any wave, a sound wave doesn't just stop when it reaches the end of the medium, or when it encounters an obstacle in its path. Rather, a sound wave will undergo certain behaviors when it encounters the end of the medium or an obstacle. Possible behaviors include reflection off the obstacle, diffraction around the obstacle, and transmission, accompanied by refraction, into the obstacle or new medium. Types of motion within waves. 1. A transverse wave is one in which motion within the wave is perpendicular to the travel of the wave. 2. A longitudinal wave is one in which motion within the wave is parallel to the travel of the wave. Sound is a longitudinal wave. Wavelength and other wave characteristic. The wavelength lambda of the sound waves is the distance between consecutive compressions or rarefactions. Another common characteristic is that waves travel with some speed of propagation, labeled v. An important relationship, valid for all waves, can be obtained by further examination. The time required for one complete vibration is t, the period of the wave. One full wavelength passes to the right in this time. This means that the wave has moved a distance lambda in a time t, so that the speed of propagation v is given by v is equal to lambda divided by t. Given the relationship f is equal to 1 divided by t, this can also be written v is equal to lambda f. The hearing mechanism. The ear properly divided into three parts. 1. The outer ear is just the ear canal, which terminates at the eardrum, tympanic membrane. 2. The middle ear contains three small bones called the hammer, anvil, and stirrup, malleus, incus, and stapes, and an opening to the mouth, eustachian tube. 3. The inner ear contains the cochlea, the organ that converts sound waves into nerve signal to the brain. The Doppler effect. The Doppler effect occurs when there is relative motion between a source of sound and a listener. The Doppler effect. The listener hears a higher frequency from a sound source, moving toward him, and a lower frequency when it is moving away from him. B. A listener hears a higher frequency when he is moving toward a sound source than when he is moving away from it. Here c is the velocity of sound in air, v is the velocity of the source in and the listener in b, and pho is the frequency in the absence of motion. As shown in this photo, the Doppler effect can be observed to occur with all types of waves, most notably water waves, sound waves, and light waves. The Doppler effect can be used to calculate the velocity of moving source. The medical applications of sound. 1. The intensity of ultrasound, used for medical diagnostic, is kept low to avoid tissue damage. Intensities of about 10 to the power of -2 watt per square meter are used, and seem to cause no ill effects. 2. Ultrasound of considerably higher intensity is used for therapeutic purposes. Ultrasound diathermy is deep heating using ultrasound of intensities 1 to 10 watt per square meter. 3. Ultrasonic sound waves sent into the body are Doppler shifted by any motion in the objects that reflect them. It is possible, for example, to measure blood velocity by observing the Doppler shift of ultrasound reflected from the blood cells. More commonly, the Doppler shift of ultrasound is used to monitor the fatal heart motion. 4. The ultrasound used for sterilization because it kills the virus and bacteria. 5. It is also used as massage tool for muscles, cure the cancer, destruction, the kidney stone. 6. Many devices use ultrasonic sound, like toothbrushes. 7. Sonic denture cleaner, or sonic cleaning device, eliminates limescal deposits. 8. Ultramax cube, multiple of uses such as cleaning brushes, dentures, burrs, diamonds, etc. These three photos show some devices that work according to sound technique.